Hi everyone, this is Miss Lim here. Today I would like to discuss Paper 2 AS level structure questions, February-March 2024 for physics. For first questions, they will like you to take which rows are SI base quantity. Base quantities is the quantity which cannot be broken down further. So the only possible answer is current and mass. Energy can be broken down further by using force times distance, and force can be broken down further by using mass times accelerations. For B, they are asking for the SI base unit of power. So before you attempt the questions, it is important for you to know what is the formula that can assist you to find out the base unit. And I'm using P equals to E over T, and E base unit will be kg meter square as negative 2 divided by time taken, so it will be your second. And you will get the SI base unit, which is kg meter square as negative 3. For question C, intensity is given in these questions, and they would like you to find out the power of the daylight incidence on the sensor. For you to find out, it is important for you to look at what is the unit representing, and we know that power will be using watt as the unit. So for us to get watt as the final answer, it is pertinent for you to look at how to remove per meter square by using the area. So you have the formula, which is intensity equals to power over area. So your power can be found by using intensity multiplied with area. Bear in mind, because there is two different units, so you will need to change the unit first to meter square before you sub in to the formula. And after calculations, you will get 0.209 watt as the final answer. For question number 2, they would like you to define acceleration. Before you define acceleration, it is important for you to determine which formula can assist you to find out the definition, which is your A equals to V minus U over T. So your V minus U will be the change in velocity per unit, which is divided by time taken. Right, for questions B, they would like you to find out the speed of the diver at the instant he hits the surface water. So as you can see from the questions, they have given you the center of gravity of the diver. So before you do your calculations for vertical component, it is important for you to find out what is the distance from the center of gravity of the diver at this position until when it hits the surface of the water. So your vertical height will be 7.8 meter, and it is important for you to break down the vertical and horizontal component. It will be easier for you to find out the answer. Bear in mind, they ask you to find out the speed of the diver, meaning to say that they would like you to find out the resultant speed. If they want you to find out the vertical or horizontal speed, they will tell you directly. So after break down all the given value, you can use V squared equals to U squared plus 2AS to find out the vertical speed. And for you to find the resultant speed, you need to use square root of 5.9 times cosine 60 squared, which is the horizontal speed, plus 13.4 squared, which is the vertical speed, and you will get 13.7 as the final answer. For question C, describe and explain the variations of the viscous drag force acting on the diver in the water as it moves downward. The viscous drag force will be depends on the velocity. So the lower the velocity, the lesser the viscous drag force will act on the diver. For Roman 2, the diver has a volume of 7.5 times 10 to the power negative 2, and the density of the water is 1 times 10 to the power 3. Show that the upthrust acting on the diver when he is entirely underwater is 740 Newton. For upthrust, you have formula which is F equals to rho GB, and all the value has been given here. You just have to sub in and get the final answer. For Roman 3, determine the magnitude and the directions of the accelerations of the diver. So for you to answer these questions, when you see accelerations, you know the fact that there will be a resultant force. So for you to know the resultant force, it is important for you to break down what are the forces acting on the object first. So you will realize that after breaking down all the forces, you will get a resultant force, which is 924.82 Newton, which is acting upward. And you can use the resultant force by sub into F equals to ma, and you can find out the acceleration's value. Your accelerations will be the same directions as your resultant force, so that it will act upward. For question 3, they have given you the diameter of the thin metal wire X, and also there is a stress over strain graph. So they ask you to calculate the force exerted on the wire by the model planet. You have formula which is stress equals to force over area. You can get the value of stress from the graph, which is at this position, by using the strain value given in the question, and you can just sub in the value. Bear in mind, you have a prefix over here, and you need to put it into your formula. After subbing all the value, your diameter need to divide by 2, and you will get 814 for the force exerted on the wire. For Roman 2, they have given you the elastic potential's energy, which is 0.31 joule, and you can use the formula to find out what is the extension first by using E equals to half Fx. So you have found the force earlier, you can sub into the formula, same goes to the energy, which is something given in the question, and you can get the extensions. After getting extensions, you can use strain equals to extensions over the original length by using the strain value given earlier, sub into the formula, and you can get the original line, which is 0.14 meter. Question B. Now, they will use wire X to replace wire Y with the same original length and diameter but double the Young modulus of X. So when there is double Young modulus, if we are looking at the diagram here, your Young modulus will be representing the stress over strain. So the gradient will be representing the Young modulus. Since there is 2 times greater right now, your gradient must be 2 times greater as well. So you need to use the value here, divide by 2, and to get the point here, and to link to the original point. For question number 4, complete the equations for this decay. So you will need to know that what is the value of a helium nucleus, which is 4,2, and you can balance the equation by just looking at the value to balance the left and right number. So you need 211 for Q at the top of the nuclear number and 82 for the proton number. State the principle of conservation of momentum. This one is quite straightforward. You just have to write the total momentum before the collision is equals to the total momentum after the collisions. When it is in the closed system, meaning to say that there is no external force acting on the system. Roman 2, they have given you the speed of nucleus P, and after decay, nucleus Q is stationary. So calculate the speed of alpha particle after the decay. You have your nuclear number according to the equations earlier. So you can use your total momentum before the collision equals to the total momentum after the collision. You have 215 for your P nucleus. So you need to multiply it by 1.66 times 10 to the power negative 27, which is the atomic mass unit. And you multiply the speed, which is your mass times velocity, equals to your Q remains stationary. So there is no momentum for Q, and there is only momentum for alpha particle. So you will use 4 nuclear number, multiply 1.66 times 10 to the power negative 27, multiplied with V. And you will get your V value, which is 1.72 times 10 to the power of 7 meter per second. Question 5. By reference to the directions of the propagations of energy, state what is meant by a transverse wave. For a transverse wave, your movement of particle will be perpendicular to the directions of the propagations of the wave. For B, a space telescope is designed to detect the electromagnetic radiations with length in the range of 12 micrometer to 28 micrometer. So state the region of the electromagnetic spectrum for these radiations. It will be your infrared. So you will need to know the estimations of the wavelength for all electromagnetic radiation. Question C, given you the time-based setting on the oscilloscope, which is 5 times 10 to the power negative 15. So we will know that for 1 cm, you will have 5 times 10 to the power negative 15 seconds. So we need to find out what is the time taken for one complete oscillation. And one complete oscillation takes 6 cm over here. So I need to find out what's the time taken for 6 cm. So after getting the time taken, I can use lambda equals to Vt and to find out what is the lambda value. As we know, electromagnetic radiations, we have 3 times 10 to the power 8 meter per second. And there you go, you will get your wavelength, which is 9 times 10 to the power of negative 6. For question 6, coherent visible light of a single frequency is incident normally on the double slit. This produces a pattern of bright and dark interference fringes on the screen. There are 7 bright fringes. Explain how the pattern of bright and dark interference fringes is formed. So you will have 2 wave form which is being diffracted, and they will superpose with each other, and they will form bright and dark fringes. Depends on whether it is a constructive or a destructive interference. So when you get a bright fringe, you will have a phase difference of 360. That will give you a constructive interference. And for dark fringes, you will have a phase difference of 180 degree. That gives you a destructive interference. For you to calculate the wavelength of the light incidence on the slit, you can use lambda equals to AX over D, and all the value has been given. Bear in mind, the unit requires to be in meter, and you need to change the millimeter to become meter before you sub in the formula. So for Roman 3, for you to find out what is the difference in terms of the new fringe separations, it is important for you to know which formula to be used. So you will have lambda equals to AX over D. When you have a shorter wavelength, you will have a shorter distance between the bright fringes. For question B, since that it is a stationary wave, for you to determine whether what is the phase difference, you just have to know that whether 2 points is between the adjacent node or it is out of it. If it's between, it will be 0 degree, and if it's beyond the adjacent node, you will have 180 degree as the phase difference. Question 7, define electric potential difference. For it to define electric potential difference, the formula that you are using is V equals to W over Q. So there is a difference between potential difference and electromotive force. For potential difference, it will be a transfer from electrical energy to other form of energy per unit charge. So the other form of energy will be depends on what is the component that you are using for you to find the potential difference. For B, the switch is open and the ammeter reading is 0.25 ampere. So determine the internal resistance R of the cells. So I will be taking this loop to find out the answer, and the sum of EMF equals to the sum of potential difference. This is your second law. So your EMF will be 1.8, and since that the loop that I'm taking, it will be negative to positive, so this one will be a positive value. And your current is 0.25 according to the questions. So you have 6 ohm, which is the voltage given to 6 ohm resistor, and this one is for the internal resistor, and you can find out internal resistance is 1.2 ohm. So when the switch is closed, you will have a variations of the current in the ammeter reading. So state whether the EMF of the cells after T1 is greater than, less than, or the same as it was before T1. Your EMF will be depends on the cells, and the cells will having the same value, and hence that it will stay the same. For questions Roman 2, by considering the effect of the lamp on the total resistance of the circuit, explain the variations of the ammeter reading shown in figure 7.2. So the moment when you have connected or when the switch is closed, you will realize that your 6 ohm resistor will be connected with lamp in parallel. So you will have your total resistance reducing. As your V equals to IR, when your resistance decreases, you will have a higher current, and that is why that there will be a change in terms of the current value in the ammeter. However, because you are connected a lamp over here, which is the filament lamp, so the longer time it is, the temperature will increase. This causes the resistance of the lamp increases and your total resistance will gradually increase. And that is why that you will have a reduce in your current value. For questions 8, state the name of the class of fundamental particles that contains a neutrino. So it will be the lepton. Lepton consists of electrons and neutrino. For B, a hadron P has a charge of positive 1e, and E is the elementary charge. The hadron P is composed by a down quark and only one other quark. So there is a formations by using one antiquark and one quark. So since they have already given you down antiquark, you will have a positive 1 over 3 as the charge value. For you to get positive 1e, I need another balance of positive 2 over 3, so I will use a up quark. You can use a top quark, you can use a trump as well. For Roman 2, state what type of hadron is P. So you will have two hadrons that you need to know. One is your baryon, another one is meson. So since this one is made of one antiquark and one quark, it will be the meson. For question C, nucleus Q undergoes radioactive decay to form nucleus R, emitting antineutrino and another particle X as shown in the decay equations. So since there is an antineutrino, we know the fact that this one will be a beta minus decay. Compare the nucleon number of Q and R. After looking at the value, after I balance all the equations, you will realize that there is no change in the nucleon number, so it will remain the same. And last one, compare the charges of Q and R. So your Q will be B and your R will be B plus 1. So your R will have positive 1 charge more than Q.